Hello, it's James here. This is part 3. Paramount have asked me to make a transformer that turns from a car into Bumblebee. Last time I did a lot of the mechanics. This is Kyla, who's a prop builder.
So this time I'll be continuing with the cosmetics, including Bumblebee's head and his arms.
And I'm going to be finishing the mechanics and doing lots of electronics and control. So it looks like a car, so that's good, isn't it? But I've had to make a couple of mechanical changes to do with the transformation since last time due to power and things like that. To pull all the pieces up, now we've got the cosmetics on. So let's have a look at that. The main difference is there's now 2 pneumatic cylinders in the back of the car here that are responsible for pulling the front of the car up before the transformer stands up. And that's because I found we just didn't have enough power with the single cylinder that I had. Now we've put all the cosmetics on things on the front. I've also positioned them so they're much higher, so the leverage angle is better, so higher at the back and much higher at the front. It was seated much further down before, and that's allowed the thing to work essentially. But it also has meant that the pulley that pulled the gull-wing doors up doesn't fit anymore, so we've got another plan for that. So the gull-wing doors are now operated by these electric actuators, so they can operate independently from the stage that pulls the front of the car back. That also means I can pop them out to get the arms up where I need to before we do the transformation. So let's have a look and see what it does so far. So far so good. Well, it's a bit back heavy, so we need to do something about that. Maybe some casters that stick out the back. For now, we sort of got to try and tip it back again. Don't know how I'm going to do that, so there we go. So what's the analysis?
Well, it works, but it's really back heavy.
It is a bit, so I'm going to put some bars in that extend the chassis to stop it tipping over with some blocks on, and I'm also going to put a brake in, which is actually there, but looks like it's in the wrong place, to stop it tipping so far over that it tips over backwards. It's time to build some control electronics for the whole thing. So it's going to be Arduino based, but we're going to have 2 remotes. One for driving it when it's a car that looks like this, and another one with an Arduino in it and a Bluetooth connection, and 2 3-axis joysticks for controlling it when it's a robot. So its main brain is going to be an Arduino Mega 2650 with half a Bluetooth link on that receives from the remote, and that's going to control everything. So then we've got some relay boards which are going to control the linear actuators, because those have got their own end switches, and they're also going to control the solenoids for the pneumatic valves. Then we've got some proper motor drivers we can feed with PWM and get feedback pots on the joints to control the arms, and the head's going to be controlled by servos off the same Arduino. So inside Bumblebee's remote is another Arduino and another Bluetooth link, and if I power up this one they should pair together. So after a few seconds we should see that it's waiting to pair, and now it's paired. And we've got this counter here which is actually running on the remote Arduino, sending the data back, because of course it's a transparent serial link, so we can have 2-way data communication. So that counter is showing me that the code is still running and it hasn't hung or anything nasty like that. And the mode of course is also kept on here, so these buttons will increment the mode or decrement the mode, and those are going to be the stages of transformation. So basically I will go up a mode, try the first part of the transformation by pressing the blue button, which will execute some function on these relays or whatever it is, or make the arms move, or whichever stage I'm at, and I can actually see whether it's worked before I proceed to the next one. Of course then I'll go up a mode and we'll do the next piece of the transformation all the way up. When we've got to a certain point, these joysticks will make the arms and the head move, and then when we're ready to transform down, we keep going up and executing the modes, checking each one for safety reasons that it's completed before we continue. So moving on a little bit, we've mounted our Arduino, the relay board for the front, which operates some of the pneumatic cylinders, and the back canopy of the car. We've got a little voltage monitor thing there and power distribution for 12 volts. And I've got my menu now, so it operates. So now I can scroll up for all the stages of transformation, bonnet eject, putting the back canopy back, coming up to putting the doors up, all the way through till we go and put the front pneumatics up. And now if I press select, you should hear that activating one of these pneumatic valves, and that relay is on. The next one is standing up, which activates another pneumatic valve, and that one's going to let air into those cylinders in the legs, but it won't let it out until this one activates. So that's right down in the next stage of transformation, to transform back into a car. So that now activates that cylinder and lets the air out. and we've got all these stages through on the menu. So I need to fit this in the back of the car and run wires out to the arms and wires out to the other relay board that operates the gull wing doors, the bonnet ejector and all the stuff at the front. But what's in the boot? Yes, it's all the electronics. We've got one relay board, a power distribution thing, and the Arduino that's paired to my handset. And on the other side, we've got a nightmare of pneumatic plumbing, including this flow restrictor, which makes it come down slowly. Let's talk about the arm motors. So we've got these lovely motors with gear heads on, and I 3D printed big pulleys that are going to drive cables that go around the big pulleys on the arm joints that we looked at last time. And we've got a number of feedback pots. So these are 10-turn pots, which can be coupled straight to the pulley on the motor, and that can give us the position, so we can drive those proportionally with feedback, and we can use PID controllers to position the arms. We've got 2 motor drivers mounted on the top of each arm, and that's going to allow us to do proportional control. So we've got PWM drivers from the Arduino in the back, and also we've got the wires there for the analog pots. And floating around in the top of the car, we've got the other relay board that operates the gull wing doors and all the stuff at the front. So under the bonnet, we've now got this cunning pulley system and some bungee that pulls the sides in. So if you remember, these slide in and the wheels slide out. And now there's a pulley on a string, and that goes all the way around, and it goes around here, and that means when this rotates, it allows this to slide in and the wheel to slide out to make Bumblebee's shoulders. Then up here, we've got a linear actuator that pulls this strap, and it pulls all the way around a pulley, and that pulls the front round. And that same rotation axis, of course, unwinds the string and causes these 2 stages to work.
Here I am making Bumblebee's head. I traced the templates onto a slightly more flexible foam than what we've used for the car panels. It should make forming the complex curves of the head a little easier. After sanding all the seams flush, I applied a couple of coats of sealer to the foam before spray painting the head the same yellow as the car. As with the details on the car, all the black and silver areas were painted by hand.
So what's this?
It's Bumblebee's head.
He's got lights in his eyes, just like in the movie.
And now I've got the rest of the parts to make as well.
So what's next?
Well, this is one of his arms. We've had to be really clever when it comes to designing the cosmetics for Bumblebee, because everything has to fit down as small as possible so it can get in the car.
Well, we're in England and it's winter, so it's raining. So I've got my tent up on stilts so I can do some tests of the robot. So those leg cylinders seem strong enough to take it all the way up with no problems, and I'm only using about 60 psi, which is about 4 bar. I've still got to sort out the wobble of the front wheel arches, which need firming up a bit, but my anti-roll measures seem to work, and the front forks rotate round and all of that stuff transforms as well. Coming down's not quite so clean, there's a bit of work to do there, but it's looking pretty good. The whole thing's got to drive along as a car, and it's going to be radio controlled, so somehow we need to power the wheels. And I'm going to do that using this. So we've got a NinjaFlex 3D printed roller with a rigid core and a T5 pulley 3D printed into it, and inside each end is some 8mm skate bearings, and that's running on 8mm studding attached to this steel. Then we're going to use this good old brushless motor that I've used in loads of other vehicle projects with a belt drive there to there, and that's going to drive this roller, and that's going to rest on the back wheel. So we've got a pair of those, and we've got the belts on, those are nice and tight, and we've got a belt tensioner on the bottom, which is some zip ties between 2 bolts. So we've got one of those fitted to each wheel each side. The little wheel runs on the actual wheel, and that seems to work pretty well. Not sure how fast it's going to go, but there should be plenty of power, and of course if I drive one faster than the other, it'll turn and it'll run on the casters at the front. So it looks like my wheel's spinning off centre. I wonder if the axle's bent under the load. But seems to be running all right, and we've got braking, so that should hold it in place as well. Oh yeah, that's pretty strong, so I think it's going to be strong enough to power it along. We have got a tensioner at the back here, which is bolted through the steel chassis, so should be okay to add more tension that pulls this round to the bigger radius of the wheel. In the bottom of Bumblebee's head, we've got a plywood frame with a 3D printed piece across with a hole in, and that makes a pivot so his head can turn. On there's another pivot, which means his head can move backwards and forwards, so he's got 2 degrees of freedom. And to make that move, we've got these 2 pegs in the back of his head now, which we're going to push around with servos. Bumblebee's head's mounted under the bonnet, and we've got 2 servos that move the head around. So now when I twist these controls, first of all we'll go into operational mode. That brings his head alive. When I twist these controls, one operates each servo that gives me that range of motion. I can't push forward too much because the ground's there. Obviously it'll be stood up, it'll be able to look forward down at you from its 3-metre height. If I twist them both, then it brings the head back. And of course we can look left and right as well by doing this sort of thing and give it quite a lot of good expression there. So I've got quite a lot of good animatronic control. I've got some motion filtering on the servos, but we could put more on. I think that'll probably do those, so we can make quite quick, abrupt actions to look at people. So let's have a look at the upper arm mechanics. So hopefully now you can see the motor fitted here with its feedback pot at the bottom and a cord that goes around the pulley on the upper arm. So if I put my transmitter into arms out mode, then it should bring the arm out when I press the button. There it goes, and that's the default pose which it will be at when it's standing, which is arms are about like that. Of course it's face down at the moment. If I scroll up into operational mode, then we should now have animatronic control with the stick on my remote, so I can move the arms around, and of course moving front and back will actually be the elbow, which isn't fitted yet, which goes on the bottom here, but that'll be the same, so I'll be able to use that stick to have animatronic control over the arms. If I scroll back up into going home mode, so where we're going to transform down, we can fold the arm back in, and the motor shut off when I let go of the button, so it's not constantly sapping power. So each arm's actually got its own battery. We've got a battery on the roof and we've got one in the boot as well, and that powers all of the electronics. And in the boot we've got a 24-litre air tank that goes up to 120 psi, yes, with a regulator, so we're going to turn it down significantly, and that gives us consistent power at about 60 psi till the actual cylinder goes less than that, but that's going to give us enough to do at least 1 transformation up and 1 transformation back. As I mentioned last time, we've got to eject the bonnet before we can transform, because in the movie it folds up into tiny pieces and it's absolutely massive, so we've got to get rid of it. So I'm going to use this to eject it. Yes, it's a drain plunger with some 3D printed attachments, so basically I've got a bungee now that pulls the top back down, and that's actually going to be locked in place, and that's going to hold the back of the bonnet. And then basically when we fill this with air, it's going to pop up, and then we've got so much air pressure that in fact it explodes and the top comes off completely. And hopefully that's going to cause a satisfying tumble of the bonnet. It's time to dirty down the Beetle and make it look like a dirty old car found on a scrap heap, just like in the movie. Kyla's using some acrylic paint watered down, brushing it on and wiping it off, building up layers of dirt. Meanwhile, I thought I'd have a go with some clear lacquer as glue and actually throw dirt at it that I found in my garden. Yep, that's more earth from the garden. And some more paint. Well, I'm pretty sure it's looking like a car. And actually got some windscreen wipers, which are actually from a car. They're the smallest ones I could find, but fortunately they don't have to be functional. Alright, that's the last video in the build series, but that's not everything!
Come back next time to see everything together.
Thanks again to Paramount for making it possible to build a life-size Transformer that turns from a car into Bumblebee. Alright, that's all for now.